Hello, I'm Kushagra, student number 240020, and this is the demonstration video of my CMP 505 Advanced Procedural Methods coursework. This coursework submission is developed on top of the last term's coursework submission, so there will be a lot of things carried over from the last term. You can see the report and the video that I submitted in the last term, and then can see what I did there. In this video, I'll talk about the main things that I've implemented for this module. Um, so first off, we start with gameplay. Um, so the main task you're given is you have to collect these coins and then take them back to your house. So you collect these coins. There must be one more somewhere. There it is. Once they're all collected, it says go to the house, and once you're at the house, the game is finished. Now this gameplay is implemented for this module, and for the gameplay we have collision detection of the player. It's using the height values from the Berlin texture and then just comparing it, and based on that comparison test, putting the player where it should be. The same sort of thing also works for this house and this streetlight model. They experience an artificial gravity if they are above the height value, and that I'll show you when I come to the UI. Other than that, this plane mesh is affected by Perlin texture, a Perlin noise 2D texture, which you can create at runtime and then apply. The height manipulation logic using a texture was developed last term. The main thing that I did was creating that Perlin texture, the whole Perlin generator, because we have the 2D texture for this height map, this terrain, and we have then a density map, a density cube for the volumetric clouds. That brings me to the second major thing that I did for this module, and that is volumetric rendering. It follows physics principles, the Beer's law of absorption, the in scattering of light and out scattering of light. The isotropic behavior of the out scattering can also be changed. We have light absorption due to the follow. All of those properties can be changed in the debug mode as well. Now let's come to the UI. This main window is majorly from last term, and it shows the details for each of the each of the things that we have in the program, such as time, the light. You have the whole detail, the spotlight, the player, and this value will change in real time. And then you can see the height value, which will again show the collision works. We have a scene enhancements. We can turn off shadows, turn off post-processing. Post-processing is again from the last term. Shadows is also from the last term. And the post-processing is basically your color grading and bloom. Then we can turn off time, so the sun will not move. It's stuck at midday. We can turn off gravity, so these objects will not feel gravity anymore. So if I go into debug mode and then move them, they will not fall down. But if I turn it on, they will. Then we have something called the flight mode. This is implemented in this term. The gravity is also implemented in this term, like I mentioned earlier. And in the flight mode, you can just fly around. You can use Q or E to go up or down. Then we have a reset button that just resets back to our sunrise scene. We have the debug window now, and we can first of all change the cloud controls. You can change the speed at which they move. Programming wise, this is just UV scrolling. I'm changing the values of the UV based on the speed parameter in X and Y axes. I can change the density of the cloud box, and this will make the whole box very thicker or have less particles in it. I can also change the ray marching sample numbers. Ray marching sample numbers are basically the amount of boxes you want to consider uh, along the ray. This loosely defines the number of particles you want to consider. But since we cannot consider all of the particles, we collect them onto, we assume that they are boxes and then we calculate our weight. Um, Increasing this will improve the quality slightly, but it will affect the performance as well. Then we have something called sigma A, which is the absorption factor, and this defines how much light is absorbed or reflected by a lump of cloud. So while this affects the density of the whole bounding box, the sigma A defines how um, each lump would perform when subjected to light. Then we can change the isotropic nature of the clouds. This is the outscattering, uh, and if it's based on a phase function which accepts a parameter, and if that parameter is zero, then a cloud particle will reflect the coming light in all directions equally. If it's less than zero, it's going to be backward bias. It's greater than zero, it's forward bias. Backward bias would be the scattering. Backward bias would be the case in which most of the scattering is opposite to the coming light direction, and then forward bias would be the opposite of that. You can change terrain texture control. This is again developed in this module. Terrain is textured based on the height values, and these can be easily changed. We can make our whole terrain very grassy if we want, and we can make it very rocky if we want. Uh, and then we can change where we want the snow to be. Uh, and yes, this can affect the overall look and make it look very good. We can also change the height map, like I've said earlier. We can generate it in real time, smooth it out. Um, we can also create some nice variations. We can create, we can change the density map of these clouds. We can only change the frequency because the output is expected in 0 to 1 by our cloud shader, because then that would be multiplied by the space density. Um, so if we change the frequency, now the clouds are very small molecules of very small collection of the gas particles rather than big clouds. If we can change directional light, spotlight, cottage positions, and everything, that's from term one. We can also change time scales again from term one. So this is all of the major contributions that I have done to my existing game engine. And to repeat, this is Perlin noise affecting our main terrain, volumetric rendering, which adheres to physics and is again affected by a 3D texture, and collision system and gameplay. Thank you. If you have any questions, please let me know.